I've seen very little content by Dr. Saladino. My understanding is he's part of the carnivore community, and that's about all that I know. But, as is the nature of the search algorithms, this video popped up in my feed, and of course I had to click on it, because I just finished reading 10 scientific studies on the topic in my detailed analysis of LDL and heart disease. Especially considering he's a medical doctor, I'm especially intrigued by his very first statement. Here it is. Take it away, Dr. Saladino.
Why I don't worry about my quote-unquote elevated cholesterol, which should say elevated LDL, elevated low density lipoprotein. Multiple reasons. Number one, becoming more specific as I enumerate them. Number one, LDL is essential for life. These kids with Smith-Lemli-Opitz syndrome don't have enough LDL because they can't make enough cholesterol. What do they do for these kids? They feed them egg yolks. They give them as much exogenous, as much food cholesterol as they possibly can in hopes that that will help remedy the body's inability to make cholesterol. They're giving them tons of egg yolks. They're giving them cholesterol and they get better. You need cholesterol to function. Why would it be bad for humans if we are otherwise healthy?
The general argument here is that we need cholesterol to function. I completely agree. We do. I don't think anyone in the scientific community would disagree, but that's not an argument. The thesis is why not worry about elevated cholesterol, not why not worry about cholesterol. Most in the scientific community would agree that we need some cholesterol. If your cholesterol is 0, you're likely dead or on your way there. But that doesn't mean that we need more than we, need. Yes, cholesterol is part of our cellular membranes, found in the neurons of the brain, the myocytes of the muscles, the goblet cells of the intestines, and many billions of other cells. But again, that doesn't mean that once all those cells are satisfied of their cholesterol fill, that we need even more of it, which is the issue. It's like saying, we need water, so therefore I don't worry about my excess water intake. Okay, but if you consume 30 liters of water, then you die. No one would say water isn't vital to life, but having none is also lethal, just as having too much is sure to have you visit your gravesite as more than just a tourist. So, I agree that we need cholesterol, but that isn't an argument for having excess cholesterol.
Second thing, LDL has critical immune functions in the human body, which I'll show you guys a little later. It interrupts quorum sensing, which is the communication between bacteria. And we know in both animal and human experiments that if you decrease the LDL, animals get more sick. And in humans who have lower levels of LDL, they have increased rates of communicable infectious disease. So LDL is an immune particle. These are two critical features of LDL. Why would something that is essential for human life be bad for us if we are otherwise healthy?
LDL has immune functions. I think this is a cool point. When we consider low-density lipoproteins, we consider the trafficking of cholesterol molecules and triglycerides across the body. The lipoprotein is the vessel, and the core is the inside of the package, containing all the ingredients our cells need, dropping off various molecules for their cellular workings. However, it always fills me with a bit of childlike excitement when we look at non-canonical mechanisms of our bodily processes, like LDL as an immune modulator. I did a bit of digging into the mechanism and found a few studies on the topic. So, quorum sensing is simply bacteria signaling to one another their population density. They will release molecules that bind surrounding bacteria and either activate or inhibit their growth. What's ridiculously cool is that LDL particles are associated with infection. According to this study, the researchers point out that people in a clinical setting experience worse infections if they have low LDL levels, which speaks exactly to Dr. Saladino's point. The reason is that the ApoB molecule attached to LDL particles can bind these molecules released by the bacteria and inhibit their ability to bind other bacteria, thereby reducing their signaling. Of course, if you have no LDL, then you have much lower ApoB, and the bacterial population can grow uninhibited, at least by this insular mechanism. Essentially, LDL particles sequester endotoxins released by bacteria. Isn't that really super freaking cool? So, Dr. Saladino is right. LDL aids in the process, and low LDL is associated with worse health outcomes. However, it should be noted that some people have low LDL in the hospital because other diseases drive LDL levels down, not because they actively try to keep their LDL at such low levels and thereby incur this added infection risk. Anyway, I guess we can move on. Oh wait, what's this? Another point being made by the researchers of the exact same study. Wait a minute, this can't be right. Check this out. Together with previous reports demonstrating that hyperlipidemia also impairs lung innate defense, these results suggest that maintenance of normal serum lipoprotein levels is necessary for optimal host innate defense in the lung. The researchers are saying that while yes, very low LDL is linked to worse bacterial infections, having elevated LDL is also linked to worse infections through impairing the immune system. Then they go on to say that maintaining LDL in the normal range is the sweet spot in relation to these infection outcomes. Well, it's almost as if having too little or too much can be detrimental. Where have we heard that before? It's like saying, we need water, so therefore I don't worry about my excess water intake. Okay, but if you consume 30 liters of water, then you die. No one would say water isn't vital to life, but having none is also lethal, just as having too much is sure to have you visit your gravesite as more than just a tourist. So, I agree that we need cholesterol, but that isn't an argument for having excess cholesterol.
The third thing is perhaps the most important. Context is everything. Context is everything. LDL, does it directly injure the endothelium and cause atherosclerosis, or is it a bystander, or is it a repair mechanism that is getting pulled in? Because if it is either of the latter two cases, it could associate with cardiovascular disease in those people who are metabolically unwell, but not be causing it. And I believe that is the oversight that is being made by physicians and the medical community over and over and over. If you repeat a lie often enough, it becomes the truth. I've even had preeminent lipidologists debate me on Twitter, which I don't really spend much time on anymore, saying everyone knows LDL is harmful. Who's to, 99.7% of the world's lipidologists believe LDL is harmful. Who are you to say that it's not? Well, I'm a human being that is thinking about this properly, and we would do well not to become dogmatic, which is to sacrifice curiosity for the sake of consistency. That is bullshit.
I, too, am a human being that is thinking. However, I didn't learn about LDL being harmful to our blood vessels merely by being taught that in my master's and PhD, but rather because I read a multitude of studies on the topic. My analysis is public, albeit long. Anyway, let me address this first aspect of point 3, and then I believe Dr. Saladino makes another point that I'd like to address. He mentions that LDL is not a causative agent to cardiovascular disease, blood vessel atherogenesis. I'm not going to pull up every study that I analyzed, but I will point out one that had a great impact on me. It's called a Mendelian randomization trial. Essentially, the researchers of this study took people with a gene mutation in their genome that caused them to have lifelong reduced LDL cholesterol and compared them against a massive other set of individuals that do not have this mutation, thereby having normal LDL levels. So, irrespective of habits, nutrition, stress, alien abduction, smoking, dancing ability, and every other factor that you can think of, the people with the gene mutation have lower LDL. And across thousands of participants with these gene mutations, they had huge reductions in heart disease risk. Yes, relative and absolute risk. We can see that evidenced here, with the boxes being samples of hundreds or even thousands of individuals with these gene mutations called SNPs or SNPs. The horizontal axis is the reduction in lifelong LDL, and the vertical axis is the risk reduction in heart disease. No matter the version of the mutation they all had lower risk due to lower LDL. Before you jump down my throat and tell me that I don't know association from my own rear end, I would encourage you to learn a bit more about Mendelian randomization trials. They're incredible studies that can, if done correctly, virtually bridge the gap between association and causation. Okay, I have other studies in mind, but let's leave it there and hear what Dr. Saladino says next.
Hopefully you guys are all still with me at this point. And the thesis that I will advance in the remainder of this podcast is that I will try to prove to you that LDL does not directly injure the endothelium of the blood vessels and that context is everything.
I'm here for it. Settle in.
The metabolic dysfunction, also known as insulin resistance, is the proximate event, the first event of atherosclerosis. And if you avoid that, if you are metabolically healthy, you can have a ton of LDL in your body and not injure your endothelium. You actually may benefit from that from cell membranes, from a hormonal perspective, and from an immunologic perspective.
We've covered this already. Even if you're metabolically healthy, LDL is an independent risk factor. Additionally, while I agree that LDL is critical for cell membranes and seems to be a benefit to immunity, we discussed how too much is still not needed and can be counter to some of those points.
So, at a very, very high level, let's ask this question. If LDL is directly injurious to the endothelium, and I believe it must be directly injurious to the endothelium in order to cause atherosclerosis de novo from the beginning, from scratch, why do we get atherosclerosis only in arteries and not in veins when the veins are within a physiologic system of low pressure?
Why do we typically experience atherosclerosis, the buildup of plaque in our arteries and not our veins? Well, he brings up a good point. But before he does, I should mention that arteries and veins are also structurally not the same. Arteries have far more smooth muscles lining the artery structure, and smooth muscles are implicated in the progression of atherosclerosis. So there is one potential reason. The second reason is a good one by Dr. Saladino. Let's hear him out.
If LDL were injurious to the endothelium, which is the same in veins and arteries, why does it not cause atherosclerosis in veins? It will cause atherosclerosis in a vein if you put that vein into an arterial circulation. But what we know is that the higher pressure of our arteries, 120 millimeters of mercury during systole, which is when the heart contracts, 80 millimeters of mercury during diastole versus much lower pressures in the veins, does damage the endothelium. Aha. So what we need for atherosclerosis to begin is a damaged endothelium. And I think that is the key here.
He mentions that arteries are in a high pressure situation. And that's true because they're taking the greatest pressure load from the heart pumping because they are the circulatory system nearest the highest pressure moment of the heart pumping. I think this is a great point, and no doubt the pressure difference could easily contribute to the issue in arteries as it does not in veins.
The LDL isn't damaging the endothelium, or we would see de novo atherosclerosis in veins. The endothelium must be damaged for LDL to become involved in the atherosclerotic process, right? Simple. That is just something that I want you to ponder over, that you must have damaged or dysfunctional endothelium. And I think the endothelium in our arteries is always being damaged by the high pressure.
Again, a very logical point, and there's likely some truth here. However, it still ignores multiple other factors, like the structural differences between the veins and the arteries, or the LDL load in one circulatory system, arteries, versus the LDL load in the other, veins, or the proteoglycan levels, which are proteins that attract the LDL particles through the endothelium, the first layer of cells of the blood vessel. Either way, blood pressure is no doubt a factor.
And I would say this. In fact, I would say this very strongly. Atherosclerosis does not exist without insulin resistance. No one ever had a heart attack. Not a single individual. Well, that's not true. I can't say that. But the vast majority of people who have heart attacks, this is atherosclerosis-induced plaque ruptured heart attacks, atheromas, are insulin resistant, whether they know it or not.
This is pretty easy to test. I do agree that people who are insulin resistant are likely people with elevated LDL and likely have other dysfunctional components of their physiology that can contribute to the rapidity of atherogenesis, cardiovascular disease. However, heart disease can form independent of insulin resistance. One of the easiest ways to test this is to return to genetics. Instead of looking at people that have favorable mutations like we did in the Mendelian trials, we can look at people who have an unfavorable gene mutation. In this case, we're looking at people who are characterized as hypercholesterolemic, which means they have a genetic disposition for increased LDL particles and cholesterol levels. So let's address this really quickly. A meta-analysis of 18 studies investigated the risk of heart disease in those individuals and found that in a quantification of risk, every study in the cohort showed an association with increased risk, except one, as seen here. Now, in full transparency, this type of analysis is not as ironclad as the Mendelian trial, so there is a potential for confounding factors. This is exactly Dr. Saladino's point. His point is that the confounding variable in all of these analyses is insulin resistance, diabetes. As you heard, without underlying insulin resistance, there is no risk of LDL being a causative factor to heart disease. Well, I have some awful news. My bedside manner isn't quite as polished as a clinician, so you'll have to excuse me if I rip the Band-Aid right off and offer the diagnosis. There have been studies that have looked at the relationship between individuals with hypercholesterolemia and diabetes, and much to my own surprise, there's actually an inverse relationship, meaning people with this genetic condition tend to have lower rates of diabetes. There may be a genetic overlap that causes this inverse relationship. So, to summarize, genetic disease that increases LDL increases risk of heart disease, and that genetic disease reduces diabetes risk, the exact opposite of what Dr. Saladino mentions. But I'd like to hit this argument with one more chair, if you'll allow a wrestling analogy. If we look at this same population, people with genetically elevated LDL levels, and we go way into childhood, we see cardiovascular disease in children. The odds that they've also developed diabetes by the ripe old age of 5 or 8 or 10 is quite small. And even if you can find some that have, they all have astronomically high LDL levels. So, which factor is more prevalent? Look, I'm not saying that diabetes and insulin resistance as a whole do not contribute to heart disease. My only argument, and it bears out massively in the data, is that LDL is one independent risk factor of heart disease, even if it isn't the only one. Overall, I disagree with Dr. Saladino, except on a few points, like the blood pressure issue impacting arteries more than veins. If you'd like to see me do more of this kind of science fact-checking, check out more of my videos in my Spotlight series. And if you're completely uninterested, check out some of my other content. And if you're still uninterested, maybe I'll do a little dance in the next video to keep you entertained. Dance with you in the next one. See ya.